When any body of mass has established a stable size or total number of elemental atoms, this overall strong force energy demand of the mass determines its gravitational properties. Masses comprised of differing elemental components will have differing gravitational properties. For example, if the Earth were made entirely of gold, it would have a much higher gravitational property than it does right now. This is because the denser an element is corresponds to it having more protons within each electron function shell of each atom, which corresponds to the denser atoms receiving more numerous electron functions in a set amount of time as compared to a less dense element whose atoms are comprised of fewer protons. For example, the Earth is a stable mass, and its gravitational properties are stable because of the stable number of all the different elemental atoms comprising it. This corresponds to the Earth receiving a stable amount of flow of static charge, basically equally spherically radial around its circumference, from the universal static grid to supply the strong force energy demands of all the atoms comprising the Earth all the way to its core. This stable or consistent amount of energy flow into the Earth or any stable celestial body of mass from the universal static grid is what determines the gravitational property of any stable mass in the universe. For example, we'll use this large steel ball and a ping pong ball for a demonstration. The steel ball is much larger and is comprised of many more and much denser atoms as compared to the smaller and less dense atoms of the ping pong ball. The stable or consistent universal static grid flow into the larger mass of the Earth is why items or smaller masses in the gravitational field of the Earth fall at almost the exact same rate. This is because the falling items or smaller masses, even though they are of different sizes and comprised of different densities of elemental atoms, are being pulled with the same exact stable amount of larger flow from the universal static grid into the larger mass of the Earth. However, the universal static grid flowing into the larger mass of the Earth must also supply the strong force energy demands of the smaller falling items or masses while they fall towards the Earth's surface. And this is what causes the smaller masses or items to be dragged or pulled with the universal static grid flow towards the Earth. This is the definition of the gravitational properties of mass. When the same two smaller masses or items of differing sizes and atomic densities are at rest on the surface of a larger mass, or the Earth for example, they display different weights in the same gravitational field of the larger mass because of two factors. The first factor is the overall size of each smaller mass, and the second factor is the density of the atoms of each smaller mass, which means that both of these combined factors determine the total number of electron functions occurring to each smaller mass in the same set amount of time. The total number of electron functions occurring in the same set amount of time are what cause differences in weights when the smaller masses are at rest on the surface of a larger mass. Stable orbits of smaller masses, like moons or satellites, around a planet or a star are partially caused by the motional trajectory of the satellite itself, being in proportionate contradiction to the direct flow of the universal static grid strong force energy flow into the larger mass. The stable orbits of smaller satellites or moons around a larger mass is also partially calculated from the result of their individual strong force energy supply from the universal static grid, creating a slight contradiction in the local direction of universal static grid flow in the immediate area around the satellite itself. And when this factor is added to the particular motional trajectory of the satellite in the gravitational field of a larger mass, this is what determines a stable orbit or a collision or resulting with the satellite moving away from the larger mass. This is also exactly why light or photons will bend proportionately or have their trajectory altered when they're near a proportionate gravitational field of a mass. I will explain light and photons later on in detail in this presentation. The distance spherically radial outward from a mass from which the universal static grid must draw in enough static electric charge to supply all of the strong force energy demands of all the elemental protons of a mass is the phantom gravitational property of a mass. This phantom gravitational factor is what determines the strength or distance that the effects of the overall gravitational properties of a mass are determined.